Let's go. What's up, everybody? Welcome to the comet.ml open office hours powered by the Artists of Data Science. Super excited to have all of you guys here today on Sunday, May 23rd. I know that we've switched the registration link, but the short link is still the same. So for those of you listening on the podcast who might have wondered why the old link wasn't working anymore, have no fear. The new link is going to be available right there in the show notes that you can use to register for all the future sessions. I'm super excited to have all of you guys here today. We got Austin in the house. We got Anna Maria and Rodney. Anna Maria, happy to have you here. I believe we connected on LinkedIn, so I'm glad you found time in your schedule to come and hang out. How have you been doing? Oh, sorry, what was that?
Hello.
Hey, how's it going?
Hi. Very
Hi.
excited to be here. I'm really grateful for the opportunity and the invitation. So I'm really glad to be here, really.
Yeah, same here, man. I'm happy to have you here. I know you've been supporting me quite a bit on LinkedIn, giving me those reactions, so I appreciate your support on that. But yeah, if you got any questions that you want to have answered, I can do my best to help you with those. Um, just go ahead and let me know. And if anybody else has questions for that matter, go ahead and let me know. We can start getting this office hour going. So I see a lot of new names in the chat, which is awesome to see. Pretty much the way it'll go is we'll just um we'll go round robin, one question at a time. So Anna Maria, if you want to take the floor and have a question, go for it. Then while Anna Maria is asking a question, if she has one, go ahead and let me know in the chat. If you have a question, I'll add you to the queue. Um, so Ed, go for it if anybody has any questions on anything related to data science, machine learning, or anything in general. I'm happy to open the floor up. Um, well, I guess a good place to start would be just have me ask you guys a question. So, what's something that you guys have been working on this past week that you feel um, kind of confused about? Let's talk about that, and let's talk about confusion and why it's okay to be confused when you're learning something new. Um, Me, for example, like I've been making my way through this book, Shape by Jordan Ellenberg this week, because I'm interviewing him later this week. And I don't know, man, it's a lot of the stuff in this book. It's interesting, but it's really hard for me to digest. And I need to go read it really, really, really slowly. But I came across some stuff in this book that he talks about topology in this book, which is just mind-boggling to me because in topology, like a square is the same as a circle, is the same as the triangle, is the same as all these other shapes. And it's like, dude, like I'm teaching my 1-year-old kid shapes and trying to teach him the difference between shapes, and it's like I'm telling him lies because in one geometry it's this way, Euclidean geometry, in another geometry it's completely different. Um, that's one thing that's had my head kind of spinning this week. But I'm excited to see if anybody else has anything interesting they've been studying or working on this week. I see Auntie in the house. Auntie, how's it going?
Hi, it's good.
Hey,
Going for
awesome.
a run again, but
Nice.
still happy about yesterday.
Yeah, right on, man. Well, go on that run and hopefully we can provide you with some good, I guess, good entertainment while you're on that run. Yeah. So I'll go ahead. I'll
Also,
put you. Yeah, I'll put you on mute in the meantime. But if you have any questions or comment, feel free to unmute yourself. But yeah, let's go for it, man. Let's open the floor up. Yes, I see Shita's here. Shita is a friend of mine. Good to see you here, Shita. But yeah, go for it, man. If anybody has questions on any topic whatsoever, let me know. But let's go through here and see if there's any interesting things that you guys have been studying or learning about this week that's got you confused. I guess I'll start with Anne Maria just because why not?
Hi.
Hey.
So I finished recently an SQL course, and what I found that is a bit tricky is how to go about waggling and wrangling all sorts of data in sort of, and that sort of make sure that your project don't fail from the data, collection stuff. So it's really frustrating. Just like you said in one of your posts, you've mentioned something about that 85% of data science projects fail from the beginning.
Hmm.
And it's really frustrating when you're just starting up as a beginner to
Hmm.
make sure that doesn't happen. And would you be having to give me some couple of hints or examples to avoid that?
Yeah, well, that's the thing. Like that, I threw that out there because that's a statistic that gets tossed around so much, and I don't even know if it's a true statistic or not. But like, if you Google 85% of data science projects fail, you'll see it come up all over the place, and that's cool if they fail. I mean, what's the consequences of that? Of its failing, right? Like, why did it fail? Let's look at the why behind the reason it failed, not just taking it as oh well, this data science thing is worthless, we should not do it. um it's more important to understand why things fail. So I mean, I had a data science project fail at work, mostly because the data was garbage, right? Like, it's not like that my methodology was not correct, it's not that my coding was incorrect, it's not that my problem formulation was incorrect. It's just the data that was coming in was complete trash and I couldn't make any sense of it. I couldn't use it, right? Um, this particular example involved trying to estimate weights of let's just say widgets. I was trying to estimate weights of widgets based on uh, the weight of entire shipment, right? I don't want to get too in depth with it, but it turned out that the input data that was coming in was wild. It was crazy. Like, there's things that should have been in, people were weighing stuff in grams and in kilograms and in pounds, and there was no consistency in weights, and you couldn't tell which unit of weight they're using because they just had weight as the column, and you can just input text into there, right? I mean, some examples of negative weights too, and I was just like, this makes no sense. So yeah, we investigate why that fails. Well, the reason it failed was because the raw data was complete garbage. Now, if we want to make this work in the future, let's work on the data collection process, right? Let's have good data management practices in place. I'm going to pause there and see if that's answer your question at all, or if I'm not, because I didn't mention SQL or anything about SQL in that response. So, Anna Maria, let me know.
Yeah, I think it does. It's just obviously going for the right kind of data from the beginning.
Mhm.
So how do you make sure that you have the kind of the right data? Make sure it's not just like you mentioned trash data, right? So how do you go about making sure you collect the right kind of data in the first place? Just because
Well,
when you're
yeah.
coming up, when you introduce to this new field, it's a bit hard to go and then start working on something when you don't know what you expect.
Yeah. So if you're fortunate in the position to be able to define up front that you're, like, let's say you're in a position where you are designing an experiment, right? And if you're designing the experiment, and you can say that, all right, these are the bits of data that we're going to collect, that's going to involve, like, so this is essentially what I was doing as a biostatistician working at a pharmaceutical company. We'd work together with domain experts, with scientists, with medical doctors, and figure out, okay, what is it that we want to do here, right? What is it? What's the end point that we're trying to disprove, right? Because that's what science should be. You should be trying to disprove some hypothesis. All right, well, let's collect data that we think will help us, but not all the data because that is expensive and infeasible. But what do we think? What hypothesis? What do we think can help us refute this endpoint? Um, and if you're in that position, that's great because you can define what data you want to collect. But most of the time, it's when you're coming into a company, where you're not designing experiments and you're just relying on data that's already been there, right? It's not as easy, right? Does that make sense? Like, there's kind of two sides of the situation there. One situation is, okay, if you're designing an experiment and you can define upfront what data you're going to collect, how it's going to be collected, what quality standards you need in order for that data to be usable, all up front, that's great. You've essentially find yourself in a situation where you can define everything. But if you're coming in and you're trying to do something based on data that the company has been collecting already, that is not as easy. Then you get into the point of, which data do I include as part of this model or whatever it is that you're doing? Then you got some issues there with selection bias and things. But I'll pause there and see if you have any comments on that. Rodney here, start with the question and work backwards to the data. Talk to me a bit more about that, Rodney. I agree with that. I agree with that framework for sure. Start with the question, work backwards to the data. Tell me more about that, Rodney.
So the way I do it is I basically start with 3 questions. What are you trying to do? Which, you can think about that in terms of hypotheses if you want, but it's more general. Why is it important? Work out why you want to do it, because that gives important background information. And the third question I sort of have is, that I pose to people is, how are you going to answer that first question? And once you've worked out how you're going to answer the first question, so what it is you're trying to do, then that will basically, one way to think about how you're going to answer the question is that's methodology, right? What methods are you going to use? And then once you've got the method worked out, then what you can do is basically you can see what sort of data is needed to make that method work or to make that method run. And the method might be encapsulated in a package somewhere, or it might be something where you have to write some code. But that once you then look at you down to that level of detail, then you can see what sort of data you're going to need to make it work. So I frame it that way, and then I find that works very well.
Yeah, definitely. Starting with a well-defined question is hands down the most important thing you can do. Have a well-defined question, have a well-designed plan of attack or an analysis plan, and then find the data that you need to help create whatever it is that you're creating. And Maria, was that helpful at all? Or is there any other questions or comments based on that?
No, it's really, really helpful. Yes. So yeah, just to understand basically what we are trying to achieve in the beginning. So not to forget the purpose of your project, right? And then go through and turn back to your question so you don't forget where you left off in the first place.
Yeah. And if you do quote unquote fail, right? Like, at least have some definition of what a failure should be up front, right? Like try to I think that if we have solid analysis plans in place at the start of a data science project, and we clearly have guardrails in place, and we clearly define what it means to fail up front, then it's not as bad, right? It's not as bad as just going in thinking that you are going to succeed and that you're going to get some awesome metric and then find out that it doesn't happen. Austin, go for it.
Yeah, I have kind of a general question. So for folks who haven't met me yet, I'm the new head of community at Comet, and I'm non-technical background. I know, some things about data science, but I'm not a data scientist myself. And one of the things I see is this sort of, what this conversation is pulling out for me is this sort of, there's like a technical side to the data science profession and work. And there's also sort of this like I think what the artists of data science, like the artistry of it, of thinking your way through a problem. When you're thinking about, becoming a data scientist or starting your journey, how do you weigh balancing, like learning the technical stuff and then training your mind or the way you think to sort of approach problems in certain ways? Like, how do those two things weigh out when you're thinking about this kind of work?
It's a great question. So just to repeat the question, how do you kind of find that balance between what to focus on? Can I have you kind of repeat that question for me?
Yeah, essentially, I think, when you're learning things, like, I guess, I don't know if there's a progression where you want to learn some of the technical foundations first and then start to adopt the mindset of a data scientist, or do you feel like it can work in reverse? Or I'm just curious how some folks have approached this who have learned, you learn the technical stuff first and then sort of backfill or follow up with learning the sort of artistry and logic of it, or is it kind of the reverse? I would be curious to hear what folks.
I think it's a balance. You can do both at the same time, right? And I think that comes from just exposing yourself to more than just like textbooks and online courses, if that makes sense, right? Because that's where you go to learn your technical skills, right? If all you do is go to a textbook, an O'Reilly textbook, a packed textbook, you go to Udemy, take some courses, and you just learn the technical stuff of what's going on under the hood, I think you're shortchanging yourself because you become a robot at that point, right? It's just steps. It's just do this step, do this step, do this step, but with no connection to reality. And I think a way to combat that is by actively looking for case studies, actively reading books, actively trying to find examples of how this particular thing is being used in the real world, right? Um, and I mean, yeah, you can read books like, like I was saying, Shape or How Not to Be Wrong, Power of Mathematical Thinking. Then there's so many other books, right? Like in our space, that give you more context, real world context about how these things are being used and implemented. But you could find some free stuff online as well, right? In white papers and research papers. I don't know if I'm answering your question at all, Austin, but I think the balance comes from just actively looking beyond just the textbook, beyond the course, and trying to find examples of how this is being used in the real world.
Yeah, that makes a lot of sense. Thanks.
Yeah, hopefully that did did make sense. I think I felt like I was kind of rambling there, but if anybody else has input, I'd love to hear. Asha, I'll go to you since you're the only one with the camera on. Sorry. No, you can talk to us about how you're balancing like learning the technical stuff and learning the kind of mindset of being a data scientist. Yeah. Oh, you're muted. Oh,
I don't think I'm good at it, even
yeah.
to answer the question, but I've been going through the textbook route for sure.
Mhm.
I've been going through books and through meetings like this, and definitely YouTube. YouTube tutorials have been my go-to for topics that sometimes with the textbook, some things you just need a video for it.
Mhm.
But I don't think even I'm qualified enough to answer that question because I don't even have the balance for it right now.
Yeah.
I'm struggling with this.
Yeah. Well, that's an important point. Struggling with it, like, right? How are you overcoming those struggles, right? So, where are you going? What kind of YouTube videos are you watching to help kind of bridge that gap?
Do I mention the specific channels or just the areas?
Whatever you'd like.
Okay, so for the technical stuff, like the usual Geeks for Geeks, and there's a math and science channel on YouTube, but also maneuvering and how to think, right? I go to a lot of these calls. This is one example. The other one there's a YouTube channel I really like. It's called Alex the Analyst.
Yeah.
He tries to explain his whole journey of how he's gone through it. And you try to understand, put yourself in his shoes and understand the thinking, if that makes any sense.
Yeah, absolutely.
But yeah, that's basically been it.
Yeah,
I don't have a grip on it yet.
Yeah, no, that's great advice as well. Thank you. I'd love to hear from anybody else who'd love to chime in on this. Please feel free to unmute yourself and let us know how you balancing learning the technical stuff versus just learning the mindset and approach of a data scientist. Ali, go for it. I think you're muted. Or Suman. Whoever'd like to go for it. Suman or Ali. Suman, you can go.
Sure. So my video is not working for some reason today. So yeah, I think I started with, of course, the online courses like Coursera. I started with some of the advanced stuff right off the bat, even without any background. And it took me, I struggled quite a lot at the beginning, and in both for the machine learning and then coding side as well. So and then I went back a little bit and tried to learn a little bit of coding and stuff. And so as the time progresses, I am seeing myself like going back to the fundamentals like as the time progresses. And but then at the same time, I'm also doing side projects, like picking a project from either your work or through the training. But in my case, I have done several projects that was related to my project, but my company, my past company, we didn't do any machine learning stuff. Well, I mean, machine learning was embedded, but we didn't do right. And so we were just trying to like educate ourselves just by having the data is there, so why not try it? So that's how I started. So, and a couple of projects, and I give you some intuition about framework and everything. But then fundamentals like mathematics and stuff. Is you, yeah,
Yeah.
I'm going back to like that route, both at
Yeah.
the same time.
Yeah, absolutely. Like hands-on actual doing stuff is going to help you gain that intuition and kind of that mindset and understanding. Just keep on doing it, right? Like, I mean, you can intellectualize stuff as much as you want, but it's not the same as actually doing something. Asha, go for it. Looks like Asha's having some audio issues. Nope. Go for it.
Sorry, I just lost the trail of thought there. I was listening to you, then I lost the trail of thought. But I wanted to say, the other thing I've been doing is I've been looking at these people you look up to in the field, right? Then you go to their GitHub, you try to see how they're solving problems through their whole projects on GitHub. That's another thing I've also been doing.
Yeah, I like that. Trying to look at how other people solve a problem and try to put your own spin or own flavor to it. I mean, that's something I do like very often. It's when I'm starting out a project and I don't know how to approach it. I will look for things that are similar, but maybe they're coming from a completely different industry, completely different kind of vantage point, and try to see what parts of that can I use to make progress on what it is that I'm working on. So I mean, that's just a ton of research as well, right? You have to dig through and see if there's anything that works that somebody else has done that you can use. So let's go to I see some good questions or comments here in the chat. So Ali, go for it.
Okay, hi. Thank everybody for being here. So yeah, I took a course when I was working, and I mean it's important to get the basics, to understand the basics, and then just go with the flow. Whatever somebody's problem comes in the way, try to resolve it. And I used Kaggle for academic research on NLP. I thought NLP is going to be like this like super duper hard thing to do, but I mean somebody has had faith in me, and I actually solved a problem for them from just Kaggle exercises on a particular NLP problem. And I mean it's important not to get frustrated with all the super duper algorithms out there that might a lot of fancy names, but once once there comes a need to them, then like the time will come for them. You know, that's like the basics work as well. And you know, if at that point we don't get this accuracy rating that we want, or this accuracy score, then that will be the time when we need to look at the complex stuff. So I try to keep it simple, stick with the basics, with what's easy to understand, like a logistics regression, regular regression, tree, all the basics, like they work, you know.
Yeah, very similar to what Suman was saying, and that's very much what I do as well. I always try to revisit the fundamentals, the basics, make sure I understand those because that's the foundation on which everything else can be built on. But like this, I'm curious, you know, what other people have to say about this as well. But kind of going into a problem before even doing anything and saying, you know what, I want to get an accuracy of 0.85, right? Like I want to get this particular accuracy, and then building a model out that doesn't reach that, and then wondering, oh well, how can I get the accuracy that I want then, right? um like I don't know if what I'm saying is making sense, but I'm just kind of thinking like from thinking out loud. Really, is from can we do this? Can we say up front that this is what we want to to achieve from this particular algorithm, right? What if the data just doesn't have the predictive power to support that, right? What if, you may want an accuracy of, whatever 0.85, but how about just having an accuracy that's some percentage better than chance, right? Um, but Suman, go for it. See, you have a question.
Yeah, I recently did a project on the natural language processing. It was my first NLP, and it was very disappointing. Uh, so my project was using Twitter data to predict sentiment, of course, and yeah, just like you mentioned, like whether the data doesn't have a power, so no matter what I do, I couldn't get the accuracy above 70%, and it was it was really, really frustrating. And I see all these projects, all this blog posts and everything talking about 90%, 95% of accuracy in NLP and LSTM and GPT, or everything is so good. But then when I actually tried to do myself, and it was very bad. I thought I had done pretty good pre-processing and everything, but I was wondering, like, if you have any comments, any thoughts, what should I?
Yeah, I would say, dude, this is 70% accuracy. Is that better than chance, right? Like you can't just get a data set and say, you know what, I proclaim that this data set should have this particular accuracy. And then whatever you don't, you build a model that doesn't get that accuracy, and then you're like, womp, womp, womp. Oh, that sucks. My project failed. No, man, like, does it do better than chance, right? Maybe your problem formulation is incorrect. Okay, let's say you're happy with the way you pre-process the data, happy with the features that you've engineered, even happy with the actual data that you're using. It could just be that what you have just doesn't have predictive power to that degree, right? Which, believe it or not, is completely okay. Like, this is the real world, right? I see Rodney here talking about change the data. Rodney, what do you mean by that? What do you mean by change the data?
Well, you can play around with some transforms of various types to when you're pre-processing. That's one thing, but you may also have to search for different features that you need to include. So basically, you use different data, and that can involve, that's not an easy thing to do because maybe there's just nothing there, but nothing available. But you might be able to get creative and find some alternative data that you can potentially use to improve your predictive accuracy.
But if you're using different data, then are you answering the same question, or are you answering a different
Good
question?
Yeah, because as long as the thing you're predicting is the same, and your problem's purely prediction, then you are answering the same question. If the problem's not a prediction problem, if it's some sort of causal type analysis, then that's a completely different story. But then you're not really predicting, are you? You're doing something else.
Yeah, exactly. Yeah. Ali, go for it.
Yeah, and thank you, Rodney and Harpreet, for bringing up the point of future engineering. I don't know if it was mentioned before I came, but yeah, like transformation is a nice word. There's so many of them. At least I came across one of the best for time transformation, like how to break down a day into days of the year, weeks of the year, and all these to come up with all these different trends throughout the year or months, or there's some if we search for that, like date transformation or feature engineering for dates, there's some good blogs out there. And the second point is the term. I mean, data science is not only machine learning. There's also the analytics part and visualization. So I did not succeed in a job interview with Coca-Cola because of this exploratory analysis kind of a thing. And so far in the past 2 years, I dealt with data science. I dealt with the like a customer requiring a particular insight So I gave it to them, but this guy, he gave me this huge data set. He was like, go find, everything that you can find. And that was really hard. So it's good to keep that in mind, that there is this kind of analysis that comes up from like just find out what you can. I don't know if anybody has experience with that, because I tried on so many groups and social media, and nobody got me an answer about where should I start with exploratory analysis, if there's like a methodology for it. So I'd appreciate it. I'll write it even in the chat if somebody wants to chat.
Yeah, I just want to make a comment on that. Go find whatever you can find in the data. Like, is that even science, man? Like, is that actually even science, person? Yeah. So, I mean, EDA. I mean, you go to John Tukey's exploratory data analysis book. That's a classic. But, I mean, but that's really old. That's probably like 60 years old, probably by this point. But he's the one who made up that term exploratory data analysis, right? So you just looking, you could start simple with exploratory data analysis. Start with just doing simple descriptive statistics, right? And then from there, moving on to like box plots and different types of plots, distribution plots, things like that. But if anybody else has any insight here, definitely chime in. I mean, I do EDA pretty basic, right? I do exploration by looking at descriptive statistics, univariate statistics. And then I'll try to see if I could understand what distribution a particular feature is coming from, right? Look at the shape of those distributions, see joint distribution plots with feature and target and between features. Um, apart from that, like, I just let it go from there, right? That's where I start. And based on what I see from there, I'll come up with some statistical test. If I need to do test, if it requires that I need to do some type of statistics, then I'll go there. I see some good comments in the chat from Adam here, though. Let's turn to Adam. I think this might actually be on a point that was unrelated to this question, but go for it, Adam. Adam says that's why a data scientist generally needs to be a domain expert, and I think that's a very apt comment regarding EDA as well. So go for it, Adam.
Yeah, I mean, it's much easier to teach a domain expert data science than it is to teach a data scientist domain expertise. The tools are out there, the Kaggle tutorials are out there. If you're a PhD and you're just trying to understand what your study does, just go on Kaggle, learn the basics, and it's very unlikely that you're going to run into something that fancy, and you might just need someone to spend a little while reviewing what you did. So I think we're going to see a trend really of people, rather than becoming data scientists, applying data science to whatever it is that they do. And we might really see even data scientists becoming consultants that get brought in when a problem really does get hairy. I do think that the days of data science being this cool career where you're this sort of generalist is definitely long since over.
Yeah, I agree with that point about everybody's going to be a data scientist in the future. Like, definitely. I don't know. What do you mean by the generalist being over? I don't know if I necessarily agree with that.
In other words, it's easy enough to learn the basics and use them and apply them now, that if you just need to do, k-fold regression or whatever it is, right? There are even packages probably now that'll do it with low or no code. So that, I think, is really being folded more and more into the Excel tier of data science, the Power BI tier of data science. The stuff that you will be able to do as a data scientist will, one, be reviewing that stuff to make sure someone didn't make a mistake, and two, if there's some technical glitch, undoing that. But I don't think that it's going to be a case of, I'm a data scientist, bring your problem to me, I will work my magic, because people have now looked behind the screen. They know what the magician is doing, and they can do it too. I even wonder if that isn't going to happen with software as well.
Yeah, it's really interesting. That I don't know why I just thought of like a like, you know, I mean, all planes are pretty much on autopilot now, right? And the pilot's kind of just there checking in and making sure things don't go awry. So I'm kind of making the analogy from what you're saying to that. Yeah, it's really interesting, Adam. Thanks for that. Appreciate that. Um, let's see if there's any more comments here in the chat. Adam, I saw a comment here from you, Adam. As soon as you have the data lined up, you can just pass it into a basic regression or clustering. Talk to us a bit about that.
Yeah, I mean, again, whatever you're talking about, k-means or linear or some logistic regression, all of that's really easy. And the hard part is, first of all, getting the data. Second, getting the right data. Third, making sure you've gotten enough and that it's varied enough to withstand the curse of dimensionality. And then you have to be a domain expert. Like if you're doing data science on, you know, I don't know, housing sales, you need to have worked in housing sales. You need a master's degree in real estate or whatever it is. You need to have that real world expertise so you have common sense, which is the thing that code always lacks, right? It doesn't just understand, right? But you can. And then once you know what the problem is and what you would need to know, right, then you need to get that data. And that's very much even more a business problem, right? Can you afford it? Does it exist? Well, you have to get it yourself. Can you make sure that the data doesn't have weird skews in it, right? So once you've gotten that, I mean, it takes you 5 minutes to, you know, throw together a Jupyter notebook and pass it through some really standard stuff that will spit out just about whatever you need to know. Now, if you're writing the, you know, Twitter recommendation algorithm, go get your PhD in, you know, in data science or analytics or CS or whatever, and publish some really awesome papers, and maybe they'll pick you up. But other than that, this whole data science thing, I think is probably going to get split up and divided over people who have that common sense, or in those rare cases where there's some technical glitch, people will build free and open source or low cost SaaS products that will take care of just about every problem. Yeah.
No, it's really, really interesting insight. So when we talk about like domain expertise, I think one thing that it does help, because I mean, knowing whether you want to use linear regression or some KNN or clustering, whatever it is, right? Having that domain expertise also gives you the language with which you can formulate the problem, right? It helps you construct a what am I trying to say? Construct the actual question that you're trying to answer, so then you can find the right methodology to answer that, right? Is that tie into what you're saying as well?
Correct. Because ultimately, there's a question that's actually being answered, right? If you want to, for example, the Army, I'm not the Army, the Air Force, they had to build some seats for their fighter planes. And they said, well, let's figure out what the average fighter pilot is. Well, what they actually discovered was that there was no average fighter pilot. Yes, each measurement, like height, leg length, hip width, had an average, but it was very unlikely that you would be average, that any one person would be average in every respect. So they had to make all of the seats adjustable, right? So that fundamental idea, the question of, the question of, oh, we're going to make a one size fits all seat, right? Well, as it turns out, you can't make a one size fits all seat, or if you do, it'll have to be adjustable. So did the data science project fail? Well, you could argue in one sense, yes, they couldn't find the average fighter pilot. In another sense, it wildly succeeded because it completely changed the course of that business. So I think the important thing is that if you're going into a data science project with the idea that you're going to come up with a certain answer, and if you don't, you're going to fail, you've already set yourself up to fail, because then it's just going to be a question of, well, what happens to be true? But if, on the other hand, you're going to say, well, I want to find out what's true, and then I'm going to adapt my business to that, then there might be some value. Otherwise, you might as well just blindly forge ahead, or be willing to just give up and close up shop entirely, I guess, if the data science project tells you wrong. But it's ultimately a question answering field. And if you're not answering a question that is going to affect some business decision or organizational decision or whatever, then you're not really going to have any success, no matter what your KPIs are.
Yeah, and so do we define failure up front? Is that what we should do when we undertake a data science project? And like, how do we define failure? How do we do that?
Well, I think there's a more philosophical question of what even is the failure of a data science project.
Yeah.
Right.
Yeah.
Is it failure if you've actually proven that the data doesn't contain what you need?
Mm-hmm.
No, because you could have given them better data. Is it failure if the data scientist leaves and goes on vacation instead of doing his job? Yeah, though in a sense, you could have gotten a different data scientist. Is it failure if they tried their best, but they just couldn't figure it out? Yeah, I think that's pretty clear, right? So I think we have to really break it up into like a business case failure where they tried to get some sentiment out of some Twitter stuff and it blew up and it turns out you can't do that. Oops. And then there's a failure of effort or execution on the part of the data scientists. And those have to be separate things.
Absolutely. Thank you very much, man. I 100% agree with that. Because earlier I was talking about a project that failed, and the failure was we did not have clean data to make a conclusion, which now lets us know what we need to do differently in our process to make this thing work. But yeah, if it's a failure of, oh man, this shit is hard, I quit, that's a different type of failure. But yeah, thanks for that insight there, Adam. Appreciate that. Auntie, go for it. I see you got some good comments in the chat. We'll go to Auntie and then we'll hear from Rodney after that.
Yeah, about the data literacy. I read somewhere that it depends wildly at the moment on like which part of the globe you're actually living in. India had a really high data literacy rate in that. I don't remember the study. I would have to find out which one it is, but India had a really high rate, and Nordics, it had Sweden, it was like under 20% was the rate. So at least here in Nordics, there's still a lot of work to be done as a generalist. At my company, I'm not even a data anything by title, but I'm the only one in my 70 person company that's even thinking about these things and trying to get the rest of the people to join in any way. So lots of work to be done still.
Yeah, right on, Auntie. Thank you. And definitely catch your breath, man. Getting winded there, huh? Let's hear from Rodney. Rodney has some great insights here in the chat as well.
Hi. So I think I was picking up on, I think it was Auntie's point in the chat and what has been just discussed concerning automated tools. And it seems to me that things are being pulled in two directions on that. So you've got this group of people who think that everything's going to move to a sort of SaaS products and low-code tools and further automation. And then, you know, at the extreme of that, the question becomes, to what extent do you need people doing sort of analytic work and and data scientists, and that they might, become redundant. And then the other side of that is particularly coming out of the academic and scientific world is the problem of reproducibility of your work and the so-called replication crisis in the sciences. And so things are going in two directions. On the one hand, there's a move in industry towards more sort of low-code data analysis products. And on the other hand, there's a move in the research world in completely the opposite direction towards more coding, more reproducible sort of type results. And it's completely unclear who's going to win out in that sort of world. But I read something on LinkedIn in the last couple of weeks where somebody pointed out that what you really need are tools to help the experts. And that a lot of the low code stuff that is being developed is aimed at helping novices and helping helping the layperson do very sophisticated types of analyses when they don't necessarily have the background to be able to understand what is coming out of that or what the particular algorithm might be doing. So I think that's a way out if software developers start moving towards developing products for experts, because that resolves the contradiction, if you like, of the two things pulling in completely different directions. Because otherwise we're ending up in a world where we've got two completely separate camps, and they're going to find it very, very difficult to sort of work together. So that's just my thoughts on that, and that was in response to these comments about where automation might be heading.
Yeah, thank you very much for that, Rodney. And I'm definitely open to hearing from anybody else that has to speak on this topic as well. But I mean, I'm not really worried about low code stuff. Like, I don't understand the negativity around it. You know what I mean? Like, yeah, if they're developed for people who aren't, I mean, look, man, it's not like there's like a sacred, like, data science council that says only these type of people with these type of skills can use this type of technology. I mean, the more people can use it and benefit from it, great. But if things go wrong and your company starts losing money, then don't blame the tool, blame yourself for having somebody who does not know what is going on under the hood use the tool, right? I hope, does that make sense? I mean, probably doesn't. I'm just kind of rambling there.
Can I respond to that?
Yeah.
I'm not saying one approach is necessarily better than the other. That's not my point.
Mm-hmm.
I mean, in a real sort of business setting, I think what you do is try to complement things. So you'll have one person working with one tool set, and another person might be working with some sort of dashboarding type software, Power BI or Tableau or whatever it might be. And so you need to cover sort of a range of things and need a mixture in your group. But there is definitely this debate that you see where people are saying things are going to be automated, automate the data scientists out of existence through. Yeah, some people are saying that, right?
Yeah, they are. Yeah.
And on the other hand, you do have a debate which points in completely the opposite direction, which is coming out of the research world and the sciences, which is the reproducibility stuff, because that's pushing you to actually write down in code form a protocol for what you've done.
Mm-hmm.
And that's completely opposite of what automated tools are doing.
Okay, yeah, thanks for that. Yeah, that think I definitely understand you a bit more clearly now. I'm all for that reproducibility camp. I think that is super, super important. And I mean, for like when you talk about frameworks, do you mean frameworks something like I don't know, cookie cutter data science or Kedro frameworks, things like that help you write code that's reproducible, or do you mean like methodologies like CRISP DM or other methodologies like that? I'd love to get your insight on that. And then after that, we'll hear from Ali.
No, I'm thinking there's a few new tools floating around on the internet where you can basically get a software as a service thing where you load your data into it, it cleans the data for you, it feeds it into, these are things like, one example would be, that doesn't quite do that, but automates the ML side, things like Data Robot. Right? Companies like that are offering sort of things, you plug it in, it'll pick the algorithm for you and it'll spit out your prediction.
Oh, wow.
So, and then you couple that with something that's going to automate the data cleaning for you.
Yeah.
Right. So the question then is, well, okay, we might firstly, the selection of methods that you can use for the analysis selection of algorithms is relatively limited. It's never going to cover the complete set of things that you might like to do. So you can't really automate that process, because someone who comes along and says, well, I'd actually like to do this differently. So then, well, which button do I press to get it to work differently, right? And it's not there, it's not available. So I think as a compromise, what you need to do is use a mix of these things in a group where, and you work with the resources you've got and the people you've got. So the people who can program, you put on that stuff, and the others you put on the more the tools that are going to be a little bit more accessible for them. But I think the way forward is going to be to redirect towards good products for sort of experts to be able to use, and sometimes those can be quite user friendly. So an example, I think an example of a product like that, which is worked really well, is in fact things like Jupyter Notebooks, right? Where everyone from the novice to the expert can use those.
Oh, man, thank you so much. I really appreciate that, Rodney. Ali, go for it.
Okay, thank you guys for recommending this Turkey book, EDA. I'll surely check it out and get my exploratory skills up. Thank you for this kind of environment where we get to help each other. So on this line of low code, no code tools, like I've worked on a project recently, and the guy was fascinated with AutoML. And I'd be like, let's do this feature engineering so I can break down the date for you this way. And this cost, because it was like in the Bitcoins kind of prediction, I told him like, we'll take this type of time periods, etc., etc. He's like, no, AutoML will do all that. I don't want you to spend any hours from my time on this kind of stuff. And I'd be like, okay, fine. So I got on, like, I'm used to just, satisfy the client, to try to make recommendation and then do whatever they want. So we did the AutoML, and it didn't give that much good results. And he ended up telling me, why don't you do some math and try to come up with some equation that we can basically like create some features for me that would help the model work better. So what I'm trying to say is that even with these low code, no code kind of environments, there still need to be done some cleaning up and some feature engineering and like that. Like I remember also working on another case. So I like Microsoft tools like Azure and machine learning. So what I do, for example, is that I will manipulate things in Power BI, and then I will take the output, upload it on Azure, do this kind of neat workflow. And because Azure is not a powerful pre-processing tool, but Power BI is. So in the end, they're all complementary. Like I personally don't think there is this all magical thing that you put data in and it will give you the results out. Although there is some tools out there like Rapid Miner, for example, would do that, will auto prepare and do the auto ML, but it comes at like, I don't know, $5,000 a month or something like that. But again, there is this whole trend of explainable AI, and I can't just put it in a black box and put my life on it, kind of a thing. Bet my life on it.
Yeah, at the end of the day, man, anything that requires judgment and wisdom, which I think only humans can really possess, you're not gonna automate that shit away. It's gonna stick around, right? You can't code away judgment, right? You can't code away reasoning and and sorry, had to mute you there, Jagesh. Can't code away wisdom, can't code away judgment. You still need that in a person who's doing the work. But I see some great comments here from Adam. Adam, go for it. I see some good comments in the chat if you want to free those up from the chat. And
yeah, I mean, basically, and I could be wrong. People have said this before and been wrong, but if you look at the trend of the amount of experience needed for an entry-level software role, it has been increasing pretty quickly over time. And you can see how the barrier to entry keeps rising and the demand for really top tier talent never really stops. And that's because the software tools just keep getting better. And so things that you would have to do by hand in the past and hire a bunch of people to do, now the software will do more or less by itself. And those tools are only getting better. And I think we'll probably look back on these software engineering jobs much like we do on the manufacturing jobs of the past. Sooner or later, I know it seemed very difficult to imagine in 1960 that you could make an automated car factory, but by 1980 everyone was driving Japanese cars made in just such a factory. And it wasn't because the cars were cheaper, they were, but it was also because the cars were better and they were more fuel efficient, they were more reliable, they would last a lot longer. The fact of the matter is that a lot of software development work is spent fumbling around. And I think that most likely as we develop ever more sophisticated low and no code tools, software engineering is going to move into a more IT and customer service role where you're going to be sitting there really just coding together whatever it is, and trying to interpret what the client wants and specify that for the machine. Now, obviously, it would take something like general artificial intelligence to replace you in that role. But I mean, I don't think that even in the next 10 years, we're going to see computer science be as attractive a career as it was for the last 10. And probably in the next 20, we're going to see it be kind of passe.
it's really, really interesting, fascinating prediction there. So what do you think will be the next thing then?
There won't.
There won't be a next thing.
No, of course not. Because if you look at the trend all across the world, it's that productivity growth is going down. We see massive headwinds of public debt and monopolization, stuff like that. And you can deal with those to an extent, but many other countries have tried many other political economic policies, and they all lead to the same place. I think that in the future, we're going to see automation eating up even more work. And unless we all want to end up driving for Uber and cutting hair, we're probably going to have to move to a more Star Trek style economy to reflect it. So no, there's definitely not going to be a next big thing.
Yeah.
Get these paychecks while you can, boys, because they're not coming back.
I mean, I don't know if I totally agree with you on that one. We should automate away the jobs that can be automated, right? Because whatever will be left over is only things that a human can do, right? And if it's only things that a human can do, it's going to be much more creative expression. It's going to be much more, uh, just leave it at creative, right? Like, I mean, we can't automate away a podcast, right? We can't automate away these types of interactions. Definitely automate away the trucks, self-driving trucks, like do all that stuff, right? We're heading into a philosophical debate here, but let's hear from Suman.
Oh, I agree with you. I don't dispute that, but I think that what you'll see is more of like a winner take all situation where there will be maybe 100 people who do podcasts and can actually support themselves. Right. So it's 99% automated in terms of how many people are still doing it.
Yeah, definitely. Interesting viewpoint. Appreciate that, Adam. Suman, go for it.
Yeah, well, I think, I mean, yeah, automation will eat up some jobs right now or in the future, but I like to believe that, yeah, one job might be killed, but there will be something new that we don't know. Like it has to balance the law of nature, isn't it?
Yeah. I mean, you look at some of the jobs that exist now, social media planner, for example. I don't know, like there's jobs now that people could not have imagined 5 years ago, 10 years ago, 20 years ago, 25 years ago, even, right? Things are, the future is, it's an interesting place. I'll tell you that much. It's unlike anything that we can imagine. That might be too strong of a comment. Ali, go for it.
Yes, so I was hearing a podcast. I don't know if there's a guy called Dennis Rothman, and he has some cool books that came up recently about explainable AI and actually just like machine learning basics for beginners or for advanced people. He's a pretty cool guy. He went through lots of his stories. But anyhow, he was saying that these tools, like these AutoML tools, oh, I think it was another guy actually. Anyhow, I'm just confusing people. I'm doing so many things at the same time. But the moral of the story is that the AutoML, the way that it works is it does some basic feature engineering for the data, and then based on the way that these features perform, it chooses the right algorithm for the model. So it is an addition to the data scientist toolbox. So I will just do my feature engineering, and instead of running 10 models, for example, I will do my model, see my prediction, and then be like, okay, let's see what this AutoML can do. What will it bring out, and then I can use whatever it used that might be better or not, kind of a thing, which should be better, but it will be better based on some heuristics or some algorithm that is following. So uh, this is the main point I wanted to add, that these are all tools kits that we can use. And yeah, I like the futuristic talk. Pretty cool stuff.
Yeah, right on. Any other questions from anyone? Let me know. We'll open it up for the last minute here or so. See if there's any question. I know some people came in very late. For example, Jagesh and uh, Shivarjan. If you guys have questions, let me know. And then there's also people who've been sitting around the audience that did not get a chance to get the questions in. So I'm looking at you, either Ihiro or I think that's the only one. So if you guys have questions, please do let me know before we start wrapping it up. Point about Dennis Rothman. He was actually on my podcast as well, Ali, a couple of weeks ago. I'm not sure if you listened to that
Yes, I
episode.
think that is where I heard that. Oh, super duper guy. Sorry.
Yeah. He's an interesting fellow. But yeah, definitely lots of good conversations, lots of good topics being discussed today. Yeah, I mean, I'm all for anything that'll help me have to do less manual work. So if AutoML can help me uh, get automate away some of the boring parts of my job, then I'm all for it. Which leaves me more headspace to think about more interesting things. Um, but yeah, if anybody has any final questions or comments or anything, now would be the time to get them in. Otherwise, hopefully, you guys get a chance to tune into the episode I released on Friday with Chase Caprio. Chase Caprio is the lead data analyst at Impact Theory. Impact Theory is Tom Bilyeu's company. Tom Bilyeu is the host of the Impact Theory podcast. Tom Bilyeu is also one of my idols, so it was really cool to be able to talk to Chase. Hopefully Tom listens to that episode and is like, oh my God, Harpreet Sahota is so awesome. I want to be on his podcast. We'll see if that happens or not. Next week, I've got an episode being released with David Gray. He wrote the book Liminal Thinking. We talk a lot about belief systems and how we should be able to have belief systems that serve us well, try on new beliefs and take off beliefs and things like that. It's an interesting conversation, interesting book as well, Liminal Thinking. Go ahead and check that out. If you have a premium subscription to Audible, it should be free for you on Audible. So yeah, Liminal Thinking, interesting book. Does not look like there are any other questions here. Thank you guys so much for hanging out. A lot of, like, I think pretty much 60% of you guys here are all new faces. So if you guys haven't already connected with me on LinkedIn, please do. Please send me a message to let me know that it was you that we're talking to. Appreciate all the great insights and comments from everyone here. I'm looking forward to see you guys on Friday during the Friday office hour session, happy hour session. If you guys get a chance to come to that, that'll be awesome. And we'll be back here again next Sunday at the same time, same link. So super happy to have you guys here. No other questions. All right. So I'll pause one more time. So if Jigesh has a question, now would be the time to get your question in, my friend. Asha, go for it.
All right, since today's the time, I felt let me just shoot it out there.
Yeah.
It's a question about when you're at work, right? A lot of the times, of course, you have this, okay, maybe not everyone, you have this imposter syndrome going on in your head. Do I know this? Do I not know this?
Yeah.
And then you also have things that you don't know. Does that make sense?
Yes, it does.
Topics that you didn't know, you don't know. So you think you know things in a certain topic, but you really don't. So it's not really imposter syndrome, but sometimes it is. How do you do a personal inventory to just know exactly where you stand in the field with your skills? And
yeah,
that's
a good question, man. That's an interesting question. I feel like I might have talked about this a couple weeks ago during one of the other happy hours. Very good question to close us off with. I feel like we're going to go on a good tangent here for the next few minutes, but I did an episode with he's the head of AI research at Ericsson, Paul McLaughlin, and he's like this incredibly smart guy, and he talked about imposter syndrome throughout that episode as well. So listen to that episode if you get a chance, and it gave me comfort to know that this incredibly smart dude that's got like PhD in like computational statistics and all this other crazy stuff and head of research at Ericsson also feels imposter syndrome. But that's, I don't know, man. Like, is let me rephrase the question, Asha. Make sure I understand it. So the question is, how do you assess where you stand, or is it how do you figure out what you don't know?
Actually both. Some things you don't know, right? Until you meet other people or you read something new, then you realize, oh, there's this whole thing I don't know. So how do you just sort of a navel gazing, let me just call it that. You just see, how do you know exactly where you stand? Are you really good? Are you in the mid? Depending. How do you take a personal inventory to know
so
what you know?
I'll speak for me personally on that first part of the question. Like, I don't do that to myself. I don't like sit and say, oh, am I a real data scientist? Do I really know this stuff? I mean, look, man, the commas and the zeros on my paycheck are real. So I'm real. So that makes me feel okay about it. I don't really stack myself up against other data scientists, right? Like, I know that I have a particular set of skills, and for me, I'm good at statistics. I can and I whatever, like I could do other stuff as well, but that's kind of like my strength. So I know my strengths, right? And I think that is what is important, is just to know what it is that you're good at, right? But not necessarily having to measure yourself up on some spectrum, like, okay, well, data scientist A is over here, data scientist B is up there. Where do I fall on that spectrum? Like, I don't necessarily do that to myself. I don't think that's a fruitful thing to do. I'd love to hear anybody else's input on this, but I see you're unmute there. Asha, go for it.
Not per se as per comparison, right? It's for, let's say, personal growth.
Okay.
You need to improve in certain areas.
Yeah.
That's more where I was heading with it. How do you just sit down and have a personal inventory? Like, do I know this? Is my code as effective as it could be? Yeah. Sorry, I don't know how to phrase it. The question is very vivid in my head, but
yeah, it's interesting. I was listening to a lecture by Alan Watts, and he was saying something. There's this vicious cycle, right? It's you, the person who are saying that I want to improve. The person that wants to be improved is the person doing the improving. So it's like a vicious circle that you get caught in. Yeah, I don't know if I have a good answer to that question, but I see Ali has his hand up, so let's hear from Ali. Then I'd love to actually hear from Rodney or Adam or Auntie on this as well. Go for it, Ali.
So I would like, these podcasts are super in our time, and this person was talking about another like super duper software engineer, and anyhow, what he said is to find a problem, like me myself, for example, I want to do this thing, quantum machine learning. I haven't touched physics since high school. Like this is, I don't know, 2015 or something years ago, but I want to do this thing. It's the next hot thing. So I find some references, some people to follow, some key people, and try to follow up what they do, listen to other sources. And what I'm saying is when we have a purpose or we have a defined problem that we want to solve, this helps put things together. So I don't have to worry about, oh, this person know this, or I don't have this, or I don't have that, but what do we want to do to get these things for it? And then it's just, each day is just, we're putting the hours for it. If we don't do one day, you put extra time the next day, and just kind of take it easy, kind of a thing. And but some would have defined a goal or a problem. This was not a goal. Even better if we have a problem to solve and help the community with.
Yeah. So Asha, can you do me a favor? Can you repeat that question again for me? Because I'd love to hear from Rodney, Adam, and even Austin on this. Austin, if you'd like to chime in, I'd love to hear from you on this as well. But can you go ahead and rephrase that question for us?
okay. My main question was, how do you do personal inventory, right? On your skills, on your soft skills, on your hard skills? How do you know exactly where you stand? Sometimes it might be imposter syndrome, but you really don't know. Sometimes it might be, you know what it is, but it's the imposter syndrome. So how do you just take a personal inventory, know exactly where you stand, know where your strengths are? Yeah, I think that's the best way I can put it.
Yeah, that's a really good question, man. I mean, I wish I wish I had a good answer for you on that. So yeah, that was the question, Rodney. So I'd love to hear from you or Austin or Adam or anybody else for that matter, Auntie as well, if you caught your breath up there.
Sure. I don't do that.
Yeah.
So I just don't bother with a personal inventory. I just try to improve. So I don't really see the need to know why you would need to do a personal inventory. You sort of, if you run into a new topic, which happens all the time, then you're not going to know about it. So what I then do is I generally follow up a little bit to see if it's going to be useful to me for stuff I'm currently doing. And then if it's might be useful in the future, I sort of make a note of it and archive it. And otherwise, if it's going to be immediately useful, then I start looking into it. So that's sort of how I work. I don't bother with keeping track of what I know or what my skills exactly are. That's
yeah.
I don't see the point in that.
Yeah, it's very, very similar to what I was saying as well. Austin, go for it.
Yeah, I think the form of that would take for me is something like, I try to pay attention to situations and circumstances where I feel comfortable, where I feel at my sort of most like flow state mentally, where the ideas are coming out and they feel coherent. And the circumstances and situations, a lot of it is for me is collaboration. So like, that's why I seek out community, or like I like, working closely with the people I work with on certain problems and things like that. So I know when I have a problem that I need to solve, I know to seek out community and not go inward. And I think like that's the kind of framing that I take towards a personal inventory, is like as I grow and as I change, just like identifying where I feel comfortable and at my sort of most, whether it's efficient or most thoughtful or most even kind to myself sometimes. That's where I try to live. And then that's my framework of a personal inventory, is just understanding where you feel. And for other people, it might be just like kind of turning more inward and reflecting that way, but I'm more of an outward. So I seek those things out a lot, and that sort of helps me.
And Maria, let's hear from you. I see a good comment here. I'd love to.
Yes, so I was just saying that I can definitely understand Asha's points, because I've been confronting with this issue a couple of times as well. I mean, even now, as I go along, I realize I need to go even deeper and deeper, and then you get more stuck, sort of like, and then you, after a while, you don't know how much you know. So you know that syndrome in like, that syndrome's, comes along, and you realize, you've actually haven't learned that much, or you haven't applied. But the trick here is to go back and just to work on the things you've been learning, and just to experiment as much as you can, and build that work up, and then confront yourself with a lot of problems related to that. So don't just run from one thing to another, just jumping to have those skills under your belt. And then when you come and you're focused, you're confronted with them, then you don't know what you're supposed to be doing, because you're stuck. So you have an idea, but you didn't actually go too deep into it, if you know what I mean. So I found myself, I need to go quite deep to understand it, and then I can carry on and learn some more.
Yeah.
So I'm not, that's the way I'm thinking.
Yeah, I like that. It's like, are you using your knowledge, or is your knowledge using you? Right?
Exactly.
Are you just collecting things to know because there are many things to know and you just want a collection of things to know? Or are you focusing on things that you think will be useful and just kind of exposing yourself to a wide range of topics, so you kind of have mental hooks, right? You have some like vocabulary to go and look some other terms up with, if that makes sense. Yeah, that's a really great input there, Anna Maria. Love to hear from Adam on this one. Adam is still around, is he?
Yeah, I often make a mistake of turning inward when I have a problem I can't solve, and I end up just spinning my wheels. It's a really bad habit. When I talk to people, I can often get some better perspective on things, ideas I never would have thought of myself. So I think it's, if you can't solve something, I don't want to sound bad, but like the problem is most likely you, not the issue. So you need to talk to someone else because they're going to do something else. I mean, we're data scientists here, right? Think of the statistics.
Mm-hmm. Yeah. It's kind of go back to something we were talking about earlier, right? Just do a bunch of research, see what other people have done, apply that to your situation. But yeah, Asha, was that, did we touch on your question there properly?
Yeah, definitely. Even got more than I expected. Thank you.
Yeah. I guess, I mean, my kind of thinking is very much in line with Rodney. Like, I don't think I've ever, like, as somebody who is all about this personal growth and personal development and always trying to constantly improve myself, I've never like sat down and said, okay, here are the things that I know, right? Like, here's all the things that because that doesn't, it's not helpful, right? It's not helpful just to write down and have it like hung up on my wall. Like, here are all the things that I know. It's more just, yeah, just, I don't know. I'm not going anywhere with that last sentence, but hopefully that was helpful, Asha.
Yeah, it was. But mostly it happens when you're moving from a different field, right? You're moving into data science from a completely different field. I feel this is when you need to know what you don't know. There are a lot of things you don't know compared to people who've been in the field for long. Right. Thanks so much. I really learned a lot. Thank you.
Yeah, definitely. I think that comes down to just reading a lot, being exposed to as much as you possibly can, right? Like if you let's say you're brand new to data science and you come across the term random forest, right? Great. And you go and you get a book and you read about what the random forest algorithm does, right? Great. that's still just a bunch of words on a piece of paper, a bunch of symbols in Greek, right? It doesn't really bring it to life. So take it one step further and say, okay, random forest, let's do a search for random forest and I don't know, uh, predicting prices, right? Try to combine it and see how that thing is actually used. And then go down more and more rabbit holes, right? You open up tabs in your mind, open up tabs on your browsers to see how things are connected. And I think that's one good way to figure out what you don't know is try to find connections, right? Like if you just have a lone piece of knowledge that has nothing connected to it, go find those connections, right? And those connections will hop you over to other little islands of knowledge that you can find other connections to. And then from there, you just kind of develop a web of knowledge and you just learn and know more. If that makes sense to anyone, it made sense to me.
Yeah, it did. Thank you.
All right, cool. You guys sign up for Anti's blog. He's got a blog all about R with a very punny name. Has to do with pirates. What's the name of that blog, Anti?
Yeah, why join the Navy when you can be a pirate?
There you go. And it's
And it's funny how about the random forest. Just a year ago, I was in a work meeting and I saw this random forest on a whiteboard. I had no idea what it meant a year ago. So I still no expert, but it's interesting to see how things move along forward if you just keep at it.
yeah,
That's my experience, at least.
yeah. I mean, trying to find connections between things, I think, is probably the biggest way to help build your knowledge. But that's it for today, guys. Thank you so much for hanging out. We've gone over a little bit. Thank you for hanging out and spending your Sunday with us. Great question, Asha, to help close off the afternoon with. Guys, take care. Have a good rest of your weekend. Be sure to tune into the podcast, join in on the Friday sessions, or next Sunday we'll be right here, same time, same place as usual, different link, but we'll have that link in the email. Take care, everybody. Remember, you've got one life on this planet. Why not try to do something big? Cheers, everyone.